Hello everyone. Today we're going to go over 19.2, strength of acids and bases. We're going to relate the strength compared to the degree of ionization and ionization constant. And we're going to write the expression for both acids and bases. Review would be electrolytes because they release electrons, they conduct electricity. Acids and bases are good conductors. Depend on the strength, I guess. And these are the new terms. One of the terms that we did not cover last section was monoprotic versus polyprotic acids. Mono means one, so hydrogen fluoride, for example, has one, versus acetic acid has three. And then another thing we need to remember is uh, phosphoric acid is a polyprotic. When it ionizes, it gives off one hydrogen at a time. So it goes from H3PO4 to H2PO4 negative, and then it gives off one more hydrogen, and it will be HPO4 negative 2, and then the last proton is given off, and it's PO4 negative 3. And then compared to strong acid is completely ionizes versus weak acid partially ionizes. And you recognize this by looking at this table right here. Completely ionizes one arrow, and then partially you have an equilibrium. It has a tendency to go to be reversible reaction. Um, Now we have ionization. The expression of ionization or ionization constant is represented as Ka, and we're going to be writing the expression, which is product over reactant. Now, the weaker the acid, the smaller the Ka. So when we look at this table right here, hydrofluoric acid is 10 to the negative 4 versus hydrosulfuric second ionization after it gives the hydrogen, then it will be 10 to the negative 19, which is much, much weaker. So that's one way of looking at it. Same for bases. A strong base is completely ionizes versus weak, which is partially ionizes, and when it gives off OH right here. And the base ionization constant is represented as Kb. Now again, if we look at ethylamine, it has negative. Alanine is 10 to the negative 4 versus ethylamine 10 to the negative 4. Ethylamine is 10 to the negative 4. Aniline is 10 to the negative 10. So this is much weaker base. So some of the problem, write the ionization expressions for the following acids. So we have HClO2. Now we know that this is an acid. It's going to donate a hydrogen. So when it donates a hydrogen, water always becomes a hydronium ion, which is H3O plus. And this one will lose a hydrogen, so it becomes ClO2 negative. And we write the expression product over reactant and put them in brackets. But then notice water is a liquid and it's not included. Remember, we cross it out and put a 1. And then we're done. HNO2. Now, HNO2 is going to donate, so hydronium ion again, always. And then the NO2 will be negative, and we write the expression not including water. Now for HIO plus water, hydronium, now IO minus, and we write the expression. Now for some bases, Now a base accepts a proton. So this one, hexylamine, it will take hydrogen from water and releases OH minus, which is indication that this is a base. And this one will have an extra hydrogen and becomes positive. And then we write the expression OH and then over the reactant, not including the water. Now again, for all of these, water will donate hydrogen. This becomes one extra hydrogen, so it's plus, and OH is released, and we write the expression. Let's do one more. Carbonate. Now carbonate is going to have the hydrogen, so it's going to be HCO3, but it's negative because of added hydrogen, and then OH is released. And we write the expression, not including the water. And the last one, hydrogen sulfuric acid, is going to gain one hydrogen, so it's going to lose the charge altogether, plus OH, and we write the expression. Okay, and I think that's that for this section. If you have any questions, let me know. Thank you guys. Have a good day.